Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. Problem basically belonging to atomic physics. Okay. As usual we first come to its statement. Okay. If if n is equal to 3, part A, what are the possible values of small l? Hereinafter we will explain what is small n and what is small l. Okay. Part B, for each value of small l in A, list the possible values of small m. Part C, using the fact that there are two quantum states for each combination of values of L and M because of the electron spin, find the total number of electron states with n equal to 3. Okay. Dear students, now we are going to its solution, but before starting its solution in a proper manner, we will first go through some snapshots. Okay. The not some snapshots, only one snapshot. Okay, this snapshot will develop a foundation regarding this problem. Okay, according to this snapshot, small n, which is principal quantum number, is either equal or greater than 1. Okay, title of this snapshot is allowed values of quantum numbers for one electron wave function. Okay, allowed values of quantum numbers for one electron wave function. Small n, which is principal quantum number, is either equal to or greater than 1. Now we come towards small l, which is orbital quantum number small l. Okay, orbital quantum number small l is either equal to small n minus 1 or at the most or less than equal either equal or less than small n minus 1, and on the other hand is either equal to or greater than 0. Okay, so value of small l is in between 0 and small n minus 1. Now we come towards small m, small l, where small l is written as a subscript of m. This is called orbital magnetic quantum number. Okay, this is either equal to or less than small l. Okay, now we come towards spin magnetic quantum number ms. This is either equal to plus half or minus half. Okay, so it is equal to plus minus 1 by 2. Okay, so dear students, in accordance with this snapshot we will solve this problem. Okay, either principal quantum number small n is equal to 1 or greater than 1. Okay, either orbital quantum number small l is equal to small n minus 1 or less than small n minus 1, and similarly orbital quantum number l is either equal to 0 or greater than 0. Okay, these are the bounds of this. Okay, that is to say, either at the most it can be equal to n minus 1, otherwise it is always less than l minus 1. Similarly, small l is either equal to 0 or greater than 0. So okay, now we come towards part A. Part A, as small l is either equal or less than n minus 1 and either equal or greater than 0, this implies that for n equal to 3, l is equal to 0, 1, 2. Okay, because small l can never be equal to n. It is always less than n at the most it can be equal to n minus 1. Okay, on the other hand, L is at the most equal to 0, but otherwise it is greater than 0. So values of L become 0, 1, 2. Okay, in view of this condition, L is equal to 0, 1, 2. Okay, now we move forward. Part B, we have to find small m and small we have to find small m for L equal to 0, 1 and 2. Okay, three values of L, and for these three values we have to find values of small m. And we have explained in our previous part of this problem what is small l and what is small m. Okay, as small m, small l, where small l is written as a subscript of m, is either equal to or less than small l, or small m, this is the modulus value, absolute value of ml, or small m mod or modulus value is either equal to or less than small l. Okay, what is the difference between these two? Okay, dear students, actually the difference between these two is that according to snapshot which we are following, in that snapshot this is denoted by small m, small l, that is small l is written as a subscript of m, while according to the author of this book, that is Paul Tipler, this is denoted by simply m. Okay, so simply m, or sometimes small l written as a subscript of m, there is no distinction. Okay, it is just a matter of discretion of the author. Okay, sometimes author denote it by simply m, and sometimes denote it by small m with small l as a subscript of m. Okay, now this implies that according to this, when there are three values of L, first of all we take first value of L, that is when L is equal to 0, M is equal to 0. Okay, because M is either equal to or less than L. Okay, so for when L is equal to 0, M is also 0. Now we come towards L equal to 1. When L is equal to 1, then m is equal to minus 1 or 0 or plus 1. Okay, according to this condition, when L is equal to 0, then m is also 0, while when L is equal to 1, then m is equal to minus 1, 0 and plus 1. Okay, because on x-axis positive x-axis is on right hand side, as negative x-axis on left hand side, and O0 is the origin. So in accordance with that arrangement, we have written it in this way. Now we come towards the third value, that is when L is equal to 2, then M is equal to in between, in center 0, and on right hand side plus values, and on left side minus values, with the condition that M is at the most equal to L, otherwise it is less than L. Okay, so M becomes equal to, when L is equal to 2, when L is equal to 2, M gets these 5 values. Okay, 0, then plus 1, minus 1, and plus 2, minus 2. Okay, these are the values of M. Now we move forward. Part C, we have part C, we have to find electron states for n equal to 3. Okay, dear students, in part B we have found m equal to 0, minus 1, 0, plus 1 minus 2 minus 1 0 plus 1 plus 2. Okay, that is to say 9 states. Okay, in part B we have found 9 states of M. Okay, how 9 states? We once again move to part B. Okay, this is part B. This is part B. This is one state, three states, 1 and 3 4, and then these 5 states, 9 states total. Okay, 1 plus 3 equal to 4, and 4 plus 5 equal to 9. Okay, 9 states of M. Okay, part C, we have to find electron states for n equal to 3. From part B, M has these 9 states. Okay, 0 minus 1, then 0 plus 1 minus 2 minus 1 0 plus 1 plus 2. We have described these 9 states in the previous step. These are 9 states. Now ms, that is spin magnetic quantum number, is always either plus 1 plus half or minus half. This implies that electron states become equal to this 9 multiplied by 2. Okay, because these are 2, either plus or minus, so this 9 will be multiplied with these 2, and hence electron states will become 18. Okay, as dear students, there is a formula for this number, for this calculation, that 2n square. Okay, when we put n equal to 1 we get 2, when we put n equal to 2 we get 8, when we put n equal to 3 we get 18, when we put n equal to 4 we get 32. Okay, I think this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.